Hey, welcome back to another episode of Detection at Scale. Today, I am here with Justin Anderson, who is the Detection and Response Security Engineering Manager at Meta. Justin, how are we doing?
Fantastic. Thanks for having me on.
Of course. Thanks for joining us today. So you've been at Meta for a little bit now. Maybe you could just tell folks listening in what you worked on prior to Meta and what you're working on now at Meta.
Yeah, definitely. So prior to Meta, I've got an interesting career. Started off in the U.S. Air Force, doing a bunch of things, everything from like leading large teams of a couple hundred people to leading small teams, doing offensive and defensive cyber operations. So that was a lot of fun. Spent a bit of time at MITRE, did more fun government-y stuff there. Moved over to LinkedIn, built the vulnerability management program kind of from scratch, built a team around it, became a software engineering manager there, kind of learned a bit about what it's like to operate in a large tech company. And over the last year and a half, I've been at Meta now, leading the detection and response engineering team. Basically, what we do at Meta is a pretty interesting play on detection engineering. We're using a process we call surface coverage, which is working cross-functionally across engineering teams, across Meta's surfaces. And surfaces for us are like the different parts of the business. We bring in security partners, we bring in purple team, we bring in red team, threat intel engineers, and we pretty systematically engage with all the different parts of the company, starting from threat model, coming up with TTPs, enumerating all the different attacks possible for that environment. We go down to detection development, workflow automation, and kind of get end-to-end detection response coverage. So obviously Meta is a big company, so it's been a lot of fun in kind of seeing how to handle some of these things at scale.
Yeah, I'm sure the scale is probably pretty mind-blowing.
Yeah, definitely the largest I've ever seen, as you can imagine.
Well, I'm really curious about diving in and understanding a little bit more of strategies and the ways that you think about securing such a massive environment. Data is probably extraordinarily meaningful and challenging for you. So maybe you can talk a little bit about how you're using data to inform your detection engineering practice and some techniques and just general thoughts that people would find interesting and useful.
As far as like using data to inform our program, as you can imagine, Meta scale, we have a lot of data just available to us just by operating in a tech company with a lot of kind of modern engineering practices like log by default, infrastructure as code. There's just a lot available there. So it gives us a lot of advantages on the detection engineering side where we don't have to go kind of scrounge up logs. I think a lot of teams have to deal with that, figure out, okay, how do I get the telemetry I need to build the detections I need? So with that in mind, we actually come at it with that systematic process I described. And we try to root our detections in data around what are the risks for the area we're trying to protect, and then what are the actual attacks that we want to detect. And I know a lot of detection engineering teams, build hypotheses. They will kind of freestyle it a little bit, figure out, what the trend of the day is, maybe use the red intel to inform some new detections. We try to start from the very basic, what is the technology we're trying to secure? What is the risk for that technology? What are the TTPs that are applicable to that technology? And that means, comprehensive, like what are all the ways that I could attack this? Some are prevented, some, we might already have detections for, some we don't have detections for. We kind of iterate on that to get to a point where we have a really solid set of detections. We really respect our investigators' time, so we want to make sure that we have very high fidelity and really well thought through detections. And also, as you can imagine, Meta, like many tech companies, has some custom stuff they build in-house that's very complex. And so we need to spend a lot of time making sure that we distill that complexity down to something where an investigator can take it and kind of run with it in an investigation.
How are you gauging things like risk?
That's a hard question. I mean, I think risk, the industry hasn't found a silver bullet for measuring risk. We try to break it down into like the most pragmatic terms, which is if I have an actual attack, if I have a TTP I'm worried about like data exfil, or if I have a TTP I'm worried about like privilege escalation on a Windows 10 host, I can find out what are all the variants of ways I can achieve that TTP. And to us, that's kind of how we bucket risk is, what are the set of TTPs applicable to that environment and what are their coverage across those TTPs? It's quite as like robust as, you'll have top-down risk, like, at the level where VPs are talking about risks they're worried about. It's very granular and specific to us, like being able to measure coverage, but we actually do use that to inform like how we talk about risk to VPs and stuff by aggregating, abstracting up and saying like, okay, across all of your corp surfaces, you're 90% covered. That'll give them some kind of gauge for understanding, okay, do we need to invest more in this area? Do we invest less? Or, should I be worried about a particular thing?
Yeah. And when it comes to coding in the logic, let's talk about detection as code. We like to talk about detection as code a lot because it's one of the key ways to actually scale detection engineering. I mean, detection engineering kind of relies on code. It's in the name. So talk to me a little bit of how you think about detection as code and what you found really valuable and useful there.
Detection as code, the nice thing about being a Meta is we have a pretty high bar for hiring. So basically everybody from EMs to ICs are expected to know how to code. So we do approach it from the stance of we are working in a environment that is all built on code, and we are building detections for attacks that are usually executed via code or scripting. And so we really kind of lean into the idea of treating it like we would treat any other software problem. So that means, you need to actually have CI/CD, you need to have control validation, you need to have good design practices, you need to have really well thought through system design for some of the more complex detections we write. We kind of take all that and we build out our detection platform on a lot of custom infrastructure we've built. And the big benefit to having this all in code is it allows us to do stuff like build end-to-end validation. So, a common problem for detections is the moment you create a detection, it starts to decay and it starts to what you thought the hypothesis was and what you thought you were detecting is going to change over time. So we've built automated ways to give us signal back to say hey, you thought you were detecting all the TTPs for this particular attack, but 10 new methods just came out over the last week that you're not aware of. And one of the detections you created, actually, that system no longer exists, or you're trying to detect on an OS that's no longer has that function anymore. So we create automated ways to get signal back to say oh, this is drifted. And we need to go revisit our detection logic. Similarly, detection as code also lets you do stuff like automate your coverage measurement, because again, at scale, coverage is a persistent problem. You want to be able to understand, am I as secure as I think I am? And if I want to put that value or the coverage value into numbers in a way where I can communicate up to the board, can I back that up with actual data? And so detection as code gives you the ability to actually represent that in dashboards, represent that and summarize it in a way where you can make better decisions.
I want to understand the signal feedback. That sounds really interesting. So the way I interpreted it was you have some mechanism of auditing your current detections and then giving you a sense of, hey, there's been some changes in attacker behavior here. We should think about updating it. Can you talk about a little how that works? It sounds really interesting.
Yeah, so back to my point about detections being software like anything else. You need unit tests to have reliable software. So our unit tests, we need the ability to simulate the firing of a detection. So that's the very base level testing for us. So make sure that all our workflows, all our pipelines, everything that generates the signal for that investigation is functioning as expected. And then also part of writing code is you often want integration tests. So is this actually going to work end to end? Is it going to function in a way that I expect? And so that bit is, we actually have a fun open source project our Purple team released called TTP Forge that we build on top of, and we do test-driven detection development. So we start with the TTP itself, and we start with the actual exploit, and we build that into a binary that you can deploy against a host. And that lets us say, factually, this attack does run on this OS because we have a runner running the background to actually execute that attack. And then we see the signal coming from our detections on the opposite end. So we get some reliable signal that things are working as expected. The challenge here too is it's obviously not exhaustive. You have times when your test environment will drift from your real environment in some places. And so obviously we spend a lot of time and effort in making sure we have parity between test environments and we're actually deploying against things that are representative of our infrastructure. But it does give us the ability to be very confident in the health of our detections.
Is this similar to Atomic Red Team?
A little bit, yeah. The Atomic Red, we work quite a bit with Red Canary on some of this stuff. So similar to Atomic Red Team, they do have the TTP runners and they have the ways you can execute attacks. This is a little bit, I think the special sauce for TTP Forge is the bundling, the packaging, the binary, and being able to deploy it to a host. Also, one area where the industry hasn't really offered a good solution is in the testing infrastructure. There's not a good way to reliably spin up commodity OS and then deploy a TTP against it and then see the signal come back. So everybody kind of has to build their own infrastructure to handle that use case. And most companies don't have either the expertise or the staffing to kind of do that. So we're in a nice place where we have, both those things. So we can go a little bit deeper, but, it's definitely something that I think it's challenging for a lot of detection engineering teams.
Oh, this is super cool. I'm digging through the GitHub repo right now, trying to understand the types of things that are modeled, and it's pretty slick.
super proud of our purple team generating that. And honestly, part of it too is the model we use for XFN heavy kind of engagements. It kind of lifts all the teams up. They get a lot of context on like, what are the actual incidents the detection response team is dealing with? And then also we get context on like, what are the challenges some of these surface engineering teams have? Because security shouldn't operate in a bubble. We're operating on top of a business that has to make revenue, has to have systems functioning. And so we get business context to say like, okay, there's going to be a lot of weird signal out of this set of systems because the business is trying something new in this area. So we make sure we have proper guardrails around like not only on the preventative actions, but like detective actions. Like, are we confident that like they can experiment safely and we can get a good signal and make sure nothing, malicious is happening?
Well, what's your approach there? Is it like timed suppression? Is it something else? Is there like another source of truth where you can get that context, or what's the mindset?
So the way we do that is from the very beginning. It's kind of like the shift left mentality from product security. Like we start from the very beginning by having a very, very firm hypothesis of, again, the TTP we want to create a detection for, and distilling it down to eliminate as much noise as possible, with all the caveats that, some environments become noisy over time. We use suppression a bit as we're iterating our detection stuff. But the biggest thing is, again, tying it back to like, can I point to a strong hypothesis of like, this is the TTP we're trying to detect. This is the mechanism I'm using to detect it. And then also, what is the context on that particular surface? Like, is this a area where there's a bunch of mobile developers and they do a lot of weird stuff with Mac OS and they have all kinds of weird software they download that runs strange commands? Like all that context is kind of built into that threat model we start with and passed over to the investigators at the tail end of that too, because, we want to give them the contextual information so that if they begin to see trends, i.e. like that part of the business is creating a lot of noise through a few of our detections, that's a signal for us to go tune, but also a signal for them to understand that, okay, the weirdness we're seeing out of the environment is actually just the nature of that part of the company. It's not necessarily something we need to be super worried about being malicious.
Yeah, that makes sense. The surfaces concept is interesting. It kind of reminds me of the conversation I had with Charles from Sony, where he was talking about like, there's like a shared baseline of things that we all are looking for. And then you sort of have like that layer on top of it that tunes it for that particular context. Does that resonate? Is that similar to how you're thinking about it?
Yeah, I'd say a little bit. Again, I think where I pull my playbook from is straight out of vulnerability management. It's just like there's a lot of analogs I see to the vulnerability management world where everybody uses a commodity scanner, they pull commodity vulns, and then they usually drown their engineering teams in tasks and tickets. I feel like detection and response, most teams are kind of still stuck in that operating model, but instead of drowning the engineering teams in tickets, you're drowning your investigators in investigations. That's where I go back to, you need a systematic model for not only, pulling down very high signal detections, and detection could be vuln or detection could be event, malicious detection. You need a way to pull that down. You also need a way to be able to continuously measure that coverage and like measure what are the parts of the company I don't have any signal and I have no ability to detect any kind of incidents. And then what are the parts of the company where I have pretty robust signal, but can I back that up with data? And that applies across both things, both management and detection engineering.
Super interesting. So we didn't talk about languages when it comes to detection, writing, and things like that. I'm just generally curious. Are you more in the camp of like a DSL, a query language like SQL, or like a programming language when it comes to detection as code?
We do a hybrid, and I'm not super opinionated on programming versus DSL versus SQL. It depends on. I say like use the tools that are available to you, especially if your company like they're gonna have probably a data lake or some observability platform, some place they're logging data. There's going to be a standard way that like SREs or software engineers interact with that. I don't think it really makes sense to spin your own solution. Often you can just leverage, is it Presto, is it Hive, is it like what are they actually using? The hard part for detection engineering, I think, is just like building the integrations and then building your own CI/CD so you can pull in that data, handle the volumes, do the parsing, have a reliable platform, those types of things.
It kind of reminds me of another paradigm that we often see, which is this real-time versus batch processing and the interplay between those two. How do you think about balancing latency?
Yeah, that one's a hard one. I think as you deal with the higher volumes of data, real-time just becomes infeasible. I think every company is dealing with larger and larger volumes of data. The ephemerality of data becomes a bigger issue too, ephemeral instances, ephemeral sessions. So yeah, it's a double-edged sword. If you want to catch a bad activity on those ephemeral instances, you need real-time alerting. I think EDR does the real-time stuff for you well enough that for the commodity things, you can kind of just lean on the EDR to do the alerting, give you the signal you need on like malware or whatever else being dropped. Batching, I think, becomes more useful if you have to build your own custom detections. And it becomes more useful because not only on the pipeline sense are you not like using massive amounts of storage, using massive amounts of compute for I/O, but you also can do back testing much more reliably. You probably have more large data sets available to you from other parts of the business. So I think people default to batch, but I'm not sure if it's like a deliberate thing where, somebody made a trade-off. I think it's just here are the tools you're given, and almost all of those tools are batch.
Yeah. And I think especially these days where it's so contextualized, it's hard to do the mental gymnastics to join data streams. That's just a hard engineering problem in general, let alone a hard security problem.
100%, yeah.
Your reaction, I was like, oh yeah, he's definitely felt that pain firsthand somewhere. Let's talk about AI. There's a lot of really interesting use cases for Gen AI. I mean, have you found any particularly in the realm of detection engineering? If you think about what we were talking about earlier around avoiding decay of rules, like is there a way where Gen AI can play a part here in quality?
I was definitely like super, I think everybody, first time using ChatGPT, everybody was like, oh my God, this is going to break the security industry. This is revolutionary. And then you spend some time with it and you're like, okay, here's where it's got, limitations and here's what it's good at. I'd say like we're still experimenting quite a bit, as you can imagine. We have Llama 2 open sourced. And so we have like our in-house models. We also play around with other external models. There's a lot of work being done to like figure out, okay, what problems does it solve well? But it does feel like we're at this boundary where, either the context windows need to get better, the models need to get a little bit more specialized for security use cases. It's like right on the boundary of becoming kind of revolutionary. But for current use cases, I mean, I think similar to a lot of teams, it's great for writing SQL. I mean, if you got like a problem that you want to describe in plain, or like a detection you want to describe in plain English, it'll write SQL for you. It's great writing Python. Like it does help speed up dev times for the team. It hasn't quite changed how we operate in any kind of meaningful way. And it is one of those things where you think about like the specialization of detection engineering in the first place, and also like specialization of how we particularly run it, where we have a heavy kind of offensive security background for our team. And we, again, use like this attacker hypothesis driven detection engineering process. It's been a little more difficult to get useful data out of it, for good reasons. Like there's a lot of safety controls on, models outputting any kind of like exploit data. It gets a little, the models get a little angry if you try to ask for specific ways to attack specific systems. You can get generic stuff like it'll spit out MITRE TTPs, and maybe it's pretty great too for like doc summarization using RAG to kind of pull down data from all your wikis and then give you good input about like, oh, this is actually how this part of your company works. And, here's the systems they use. But, I think like most teams, you get that data back, you won't ever use it without double checking it. So the amount of time savings at this point is like not substantial.
What about in response?
Response, I think, is much better. I think especially for teams that have like large SecOps footprints. Like I mentioned before, we tend to use like, we hire a bunch of very good investigators. It's not as big a use case for us, but I do think, a lot of the analysts are getting a lot of benefit out of just like, you see a weird process name you've never seen before. It's like great for me. Like, what the heck does this process do? Like, is this normal for the system? You can, have free flow of thought answers to like things you run into during investigation. And actually, you can incorporate that into your investigation platforms. And like, I know, obviously Microsoft's offering I forget what they call their version, the Copilot for the Sentinel.
Security Copilot?
So, yeah, exactly. Security Copilot.
Yeah.
So like, I think vendors are starting to like, leverage more of those capabilities in their products. And I think it's pretty exciting. I do think also for the workflows investigators run, it helps kind of reduce the mental burden of having to think through each investigation step and, make sure you don't miss any steps. So that's solid as well. And I do think at some point I feel like a lot of the trivial investigations that come up sit kind of similar into a bucket like customer service, where it's like a bunch of repetitive things you have to do over and over and over with small variations. And, LLMs are amazing at that. So I do see maybe back to like detection as code being a critical thing for the industry. I do see the need for the manual investigators, the manual detections, like kind of evaporating over time. And, we're going to be leaning more on engineering expertise, not only for detection engineers, but also for investigators.
And is that the mentality still today? I mean, you mentioned that there's a pretty high emphasis on programming. Do you need to be a developer to really do response on your team?
Not across the board. And there are, I've got a lot of respect for investigations as a domain. It's definitely, I come in more from the engineering background, and, it's got its own craftsmanship standards. You've got your own skills you need to build up. And investigators, similarly, like I work with some world-class investigators that just will find the needle in the haystack consistently in a way that like kind of blows your mind every time. So a lot of respect for that. To find that needle in the haystack at a company like Meta, though, you need to know how code works to some extent, and you need to know how microservices work, and you need to know how like large scale systems work. So there is a little bit of like a baseline understanding. I don't know if that applies across like all companies. SMB is probably not as applicable, smaller environments probably not as applicable, but I do see, it seems like the trends, the winds are blowing more towards stronger engineering skills and, some investigation skills versus like, I'm not seeing a SCOTA back to full manual investigations and just, fighting through a bunch of alerts. Like I remember back to my early Air Force days where they're using ArcSight as like their SIM. And they had this weird structure where you had a team of, I want to say like 100 investigators and then like 8 detection engineers doing tuning. And they had something like 1 million alerts a day, and they got through 1,000 of them manually. And it was just like drinking from the fire hose every day, no ability to pull signal from noise. And I look at like, modern SIMs like yours, and it's funny seeing kind of how far we've come in the ability to, tighten those feedback loops between investigator and tuning. But I think a lot of that is reliant on people who know how to build and who know how to deal with Python at even a basic level so that you can, automate away a lot of these woes.
I can't imagine triaging 1,000 alerts a day. That's mind blowing. Just like the room for error is so high,
And also like the 1,000 alerts were not selected in any kind of meaningful way. And, it's just, it was exactly. Yeah. There's no way you need your software, you need your systems to do that work for you. A human cannot ingest a million of anything and figure out like what is the most important 1,000 things out of these millions. Like we're just not built for that. That's what we have computers for. So, I think having the skill set to know how to tackle large scale systems like that is just so fundamental. And the other thing too is like you step into an organization and there may be some existing processes, there may be existing systems, there may be like a lot of debt as far as, process debt or tech debt. And sometimes it gets to a point where like the logical thing to do is like blow away the old system, install a new system and like start over from, core principles versus trying to cut out the noise. And so I see some teams kind of caught in that trap where, they don't want to get rid of the old system, but there's so much tech cleanup that would have to be done to even get any kind of signal out of the noise that, the investigators in particular, I think feel trapped by that. And so that's like, it's one of those things where it's important for morale and effectiveness.
Yeah, for sure. I mean, I think there is a pretty good opportunity to have LLMs do that first set of pattern matching in a lot of ways. I mean, that's what it's great at, right? It's like, here's a ton of information, like help me find the connections and the patterns. What it's really bad at is like, hey, go analyze these petabytes of logs for me, please.
Yeah, great pattern matching if you can give it enough context. But that's also the challenge too, is like LLMs are expensive still. And like models are getting cheaper. Sure. We're getting better. Again, like Llama 2, I think, we've got our 70 billion variant will like run on a M2 Mac now. So it's getting to a point where like we'll have distributed LLMs, and that'll give us the ability to maybe like parallelize some of this or like work on building context within like smaller environments. But that's still like, I think like we'll see an unsolved problem, and one area where like, I think we're going to see step changes, improvements over like the next year or two, and really just kind of fundamentally change how we do investigations.
Yeah. As we've seen in the last few years, right? Like maybe the last like 2 years, right? How many step function changes have we seen there? It's pretty remarkable.
Yeah, no, that's true. On the converse side too, it is funny how some things never change. And like, I think security is a fun one because most of the industry, if you look at like software engineering as a profession and how it's changed over time, I don't think a software engineer of 20 years ago would recognize a software engineer of today and what they're doing. But if you took like a detection, well, and not even detection, but like an investigator from like 20 years ago and brought them up to today, I think the toolkit would be surprisingly similar as far as like you're still looking for events on the same old OS. Your EDR is better, like it catches some more of the dumb stuff, but also attackers got better. So like the bar keeps raising. So as we get better at what we do, attackers get better at what they do. And so, I mean, keeps us all employed, I guess.
That's true. Keeps us all employed. It's a funny like cat and mouse game in a lot of ways. But, I'm hoping that with LLMs and other advancements there, just in terms of cloud native, it's like we're really going to like up level as defenders. So I'm excited about that.
Yeah, likewise. Yeah, I'm really excited. And again, I think it seems like the innovation is happening in pockets. So it's going to be one of those things, I think, where, some venture-backed startup is, revolutionizes detection and response, starting from, the small startups. That's why I like to keep in touch too, like across. That's why tech industry is fun too, is like you see all these small engineering teams come in with very novel solutions. And it's usually not the large companies or like the older companies. It's just a bunch of small teams experimenting. One person finds an insight and the industry is really great about sharing it out. So yeah, pretty excited for this next year.
Yeah, me too. Well, Justin, this has been awesome. I've learned a lot by listening to your methodologies and your insights, and would love to wrap up with our typical 3 pieces of advice for folks listening in. So what's the knowledge that you can drop on us?
The 3 pieces of advice I'd have, and again, like informed by kind of seeing how things worked at LinkedIn, seeing how things worked at Meta, I'm a big fan of like this product view security. And one of the best frameworks I've seen for like kind of product driven security programs is understand, identify, execute. Basically, that methodology applies everywhere. It kind of works like OODA loop. So make sure when you're building out your program, you're spending the time to understand what you're trying to solve for, identifying levers you can pull to like get impact, and then execute against that plan pretty aggressively. That's my 3 takeaways: is understand, identify, execute. Just run that playbook over and over, and you'll I think see some big returns to how fast your program grows.
I think that's just good life advice in general, right? It's like understand, have intention, and execute.
Exactly. Yeah. Just run that playbook for everything. I should probably use that at the gym more so I can actually increase my lifts a little bit better.
Progressive faster. Overload.
Yeah.
Execute and lift more.
Yeah, exactly.
Awesome, Justin. It's been great chatting with you. Looking forward to staying in touch and excited for this to come out. So thank you so much for the time.
Yeah. Thanks again for having me, Jack. It's a pleasure.